critical thinker, you might ask, why is that even a U sub problem? I thought a U sub was really used for chain rule kind of deals where one looks like the derivative of the other. And that is by far the 90% of the time use of U sub. It's usually a chain rule, one is the derivative of the other case. But I think you'll agree that this is not a one is the derivative of the other. X plus 2 is not the derivative of x plus 1, and x plus 1 is not the derivative of x plus 2. So why would you use U sub here? About a 10% of the time case, U sub is used for what I call the unfortunate sum problem. I have nowhere to go with this. I cannot distribute the way it is because this has an exponent of a fourth, and that doesn't, there's just no way to combine those two the way it is. And I cannot integrate each one separately. I know that I cannot integrate two pieces of a product. I can't do that. So I'm stuck. There's nowhere to go. Well, U sub, used creatively, gets around that inability to combine those two. If you let U equals x plus 1, then this part here will become U to the 1/4. And that, rather than a sum to the fourth, is a single term to the fourth. And I'll be able to distribute. Right now, that's in a second. Now, the next thing is that, all right, I have to account for everything else. I have substituted in for this. I need to know what is x plus 2 equivalent to in U terms. Well, if U is x plus 1, then what's x plus 2? The question is x plus 2, what is it? I heard somebody say U plus 1. One way to do it is just to say, well, I'll just add 1 to both sides. And x plus 2 would have to be the same as add 1 to U, so U plus 1. Now, if I substitute that in, then I've just dealt with a really thorny issue. I couldn't combine before, but now I can. It's U to the 5/4 plus U to the 1/4. Now, what I haven't done yet is still deal with the du, dx and du. I know students feel like that's not an issue. That's an issue. It's a big issue. You need to make sure you deal with the differential. To know what to put in here, you go back to your original statement and you take derivatives. What is the derivative of the left side and the right side? 1, yeah. So du dx is 1. Now we typically bypass that step and go straight to the, if I move the dx over, du then is equivalent to dx. So I can actually straight up substitute for that dx with the du. All right. Now, with that little bit of trickery, I can now use the power rule. What's the antiderivative of U to the 5/4? Raise it by 1. So U to the 9/4 and divided by 9/4 would be the same as multiplying by 4/9, right? The next one, raise the power by 1. So U to the 5/4 divided by 5/4 is the same as multiplying by 4/5. All right, the last thing I have to do is sub back for the u's with what they were in x terms. 4/9 of blank to the 9/4. And in u's place, I sub back x plus 1. And 4/5 times something to the 5/4. And in that place, I put x plus 1. Okay? Now, that is another case of U sub. On the first section, then, I told you what U sub to make. You just need to be able to execute. The second level of U sub is to be able to decide for yourself what to make U. We talked about that yesterday a little bit. So number 6. Is there a 6 down below? Is this what we have? Sometimes I make changes to worksheet. This is exactly like you have? Okay, cool. All right. Now, that is a, I know it's not a product, but it's kind of like a product. It's a quotient. So, in a way, it's like a chain rule because you have a product in it. I'm thinking, oh, maybe U sub is one the derivative of the other. That's what decides for me. Yes, go U sub. All right. So, remember yesterday we talked about U sub you choose u by saying what's the inside of the composite function. Now this is the composite function. It's a function within a function. So I would hypothesize that we should let u equal the inside of it, x squared plus 2x. Now, I'm hoping that'll work out. After you've done that, then you say, okay, well, if I take the derivative on that, what would I get? 2x plus 2 dx, yeah, if I move the dx over. Now, is that kind of what I have up there? Sort of. What's wrong with it? It's got an extra 2. So how could I make it like what I have, x plus 1 dx? Take out the 2 and divide it over. I could say x plus 1 dx is the same as half of a du. Now I think I'm ready to substitute. In place of this, x plus 1 dx, what do I put? Du over 2. And can I put that over 2 out front or the half out front? Go for it. Okay, what about the denominator? Instead of that thing to the third, it's u to the third, which really amounts to integrating u to the negative third by power rule. So what is the antiderivative of u to the negative third? If I raise it by 1 and divide by the new, u to the negative 2 over negative 2. Remember, you're adding 1, negative 3 plus 4, so it goes to negative 2, not negative 4, which would be down 1, right? And so, plus a c, last but not least, I got negative 1/4. I could call it to the negative 2, or I could put it back in the denominator, but it's u squared in the denominator, and in place of u goes x squared plus 2x. Is that ringing a bell? Yes. All right, now this takes a while. You'll gradually get good, and then pretty great, and then you need to be a master. This is a crucial skill. All right. Now, there are indefinite intervals or antiderivatives. That's what you use of. But now you need to talk about what about a definite interval. So like I'm finding the area under a curve, and I have those limits. How do I do this use of then? What's different? Okay. This has a kind of abstraction to it that I just think is so cool, but we'll come to that in a minute. All right? Check this out. This is a common use of candidate because I've got a product and one looks like the function or the derivative of the other. Yeah? Are you with me? All right. So what is u? U is x plus 2, x squared, okay? If u is x squared, then what's du? What's the derivative? 2x dx, yeah? Now, I have x in dx, but I don't have the 2. So to isolate the x dx, I would then divide over 2, and so x dx is du over 2. You follow? All right. This is not what you have. Okay, no wonder you're so confused.
That's why I said.
You said something? I didn't hear you say something.
I said x plus 1 and you said.
X plus 1? What x plus 1? I don't know what you're talking about.
The right.
The right one? Are you sure something's not incredibly funky here?
Yeah, I'm positive.
Oh, yeah, how about that? That's totally different. No wonder you're so confused. I wish I would have changed this. I like my slide better. All right. Sorry about the confusion. Once again, I made changes to the work, but not the slides. Okay. Okay. Sorry, does this match what you have? Is that what you have? Okay. Oh, this is, now I know I made that choice. All right, so here, u is, now I would like to make the substitution so that I can distribute this a little better. So I'm going to let u equal x plus 2, okay? And you'll see why that benefits me in a second. But if u is x plus 2, then what's x equal to? Hello? If u is x plus 2, then isn't x u minus 2, yeah?
Oh, yes, yes.
Are you with me?
Yes.
So what's x plus 1 then? U minus 1. Do you agree?
Yes.
All right. Now the reason I wanted that is because I need to know what to put in for that guy in addition to that guy. So at that point, what I've figured out so far is that x plus 1 can be replaced by u minus 1. The square root of x plus 2 can be replaced by the square root of u. And that's all I've exchanged so far. You with me so far? All right. Looking back at this statement, if u is x plus 2, then what's du? dx. So I can replace dx with du. All right, now, here's the new part of the day. When you have limits of integration, those are x values. That's like on an x graph, it's going from -1 to 2 on an x graph. If those are x values, then it would be 100% lie to rewrite them here, because this integral is about u, not x. So on a definite integral, you must find the u values that correspond to those x values. Now, that -1 for x, if I put -1 in for x, then u would be -1 plus 2 or 1. So that bottom limit in u terms would be 1. When x is 2, u is 2 plus 2 or 4. Now, I know it feels kind of funky, but you really have taken this curve that has some kind of look from -1 to 2 and exchanged it for a kind of different curve in a different region. The cool thing is, though, that these two areas, they're the same. Different curve, different region, same area. And that's possible. Couldn't I, between two different curves, couldn't I find a way to make two areas the same? And so it's possible that two totally different curves and two totally different regions have the same amount of area in between. It's not actually that big a deal. Now, let's go back here and finish. How would you integrate this? What's the next thing you would do? Anybody? Okay, can you integrate it the way it is, as a product? You cannot. Can you integrate a sum? Can you make it a sum? How? There you go. Okay, u to the 3/2 minus u to the 1/2. The whole reason we made that u sub was so that we could distribute. We couldn't distribute in the original part. Now we could. U to the 3/2 antiderivative. 2/5 u to the 5/2. U to the 1/2 antiderivative. 2/3 u to the 3/2. Now, here's the cool part. Normally, we would then sub back for u, right? But don't I know the u values that I want to use? In other words, those 1 and 4, those work for you. So on a definite integral problem, on definite integrals, when you change the limits, you change the limits of integration or the bounds, and you don't sub back. So if I were to evaluate this, I would have to do 2/5 of 4 to the 5 halves minus 2/3 of 4 to the 3 halves in parentheses, and 2/5 of 1 to the 5 halves minus 2/3 of 1 to the 3 halves. That's the fundamental theorem of calculus, or how to do a definite integral. Antiderivative, and then at the upper limit minus at the lower limit. What is 4 to the, let's do the 1/2 first. What's 4 to the 1/2? 2. Then to the 5th power. What's 2 to the 5th? 32. 2/5 times 32 minus 2/3 times. What's 4 to the 3/2 power? Square root first to do the half, then cube. 8. Minus, the ones are a non-issue, it's just minus 1 times 2/5 and 1 times 2/3. All right, so 64/5. I put these two guys together in my mind. 64/5 minus 2/5. What is it? 62/5. Negative 16/3 plus 2/3. Negative 16/3 plus 2/3. Negative 14/3. Yeah? Common denominator is 15. 62 times 3, 186. 14 times 5, 70. 186, take away 70. 16 over 15, which does not reduce. Here's your answer. Okay. Now, that said, then, try this one. Actually, never mind. This is not a U-try. This is a simple one. Now, this one is a very common U-sub error, because people look at that and they don't think, oh, that's not a U-sub because it's not a function within a function. But is negative x within e to the a function within a function?
Yes.
Yeah, it's a simple function within a function, but it is a function within a function. This is actually the most common U-sub error, is when it doesn't look like one. It's not two terms slapping you in the face, all right? So, what is u? What's the function within the function? Negative x. Therefore, what's du? Negative 1 dx, or negative dx. Now, I don't have negative dx, I just have dx, so isn't dx equivalent to negative du? All right? So in terms of where I'm at now, I'm going to sub for e to the negative x with e to the u. Dx will become negative du, which I could surely put that negative out front. What about the 4? Is it doing anything for me? No. So let's put that out to the front. And then the last thing is, on a definite integral, you must change the bounds. So the idea is this. If u is negative x, then when x is 2, u will have to be negative 2. That lower bound is negative 2. When x is 3, u is negative 3. All right. Perfect. Now we're ready to roll. That negative moved out front is negative 4. And what's the antiderivative of e to the u? E to the u. From negative 2 to negative 3. That's weird that that goes backwards, by the way. That means the u is negative, but that's okay. Negative 4 times. So what do I put in first? Negative 3 or negative 2? It's at the upper limit. The upper limit is negative 3. Minus e to the negative 2. That answer is okay. You could also, distribute. You could say something like 4 over e squared minus 4 over e cubed. That's an equivalent answer on a multiple choice. But that's the idea. On a definite integral, you do your u sub, but you change the limits and you don't sub back. Try it on your own, or with your math amigos. Feel free to say, math amigos, help me. If we're there. The u minus 2 here, if I decide that u is going to be x plus 2, then u would have to be q over 2. So just bring that first. Why can't you be a love? Check your u. If you said let u equal natural output, you're on the right track. Proceed.
Oh, no. It's a natural argument.
So when you find it out, don't look to the use Okay, hopefully your equivalent integral is the integral from 0 to 1 of u cubed du. Yes? Okay, excellent. Now, the whole objective is to make your life easier. Did that make your life easier as far as integrating?
Yes.
Yeah. What's the antiderivative? One fourth u to the fourth. That was agonizing. Okay. Do I need to sub back for u?
No.
No, not in a definite integral problem. So it's just 1/4 of 1 minus 0 or. Okay, try the next one. Not quick or not sure that question right now. Okay. Oh, it's that's odd. Have you chosen u yet? What should you use? 2x minus, I'd go bigger, a little bigger. 2x minus pi over 6 is good. Oh, okay, sorry. Therefore, du is based on that u choice. So it would be 2 dx, yeah? I don't know. So dx would be then 1/2 du. Because that 2 is not there. Sure. to do? Good? Yes? Work? How are we doing back row?
Really?
Yeah.
Cool. Probably gonna rely on you.
That's why I just suck it. I know. I wish it was
Uh-huh.
Yes.
How are we doing, people? Good? Okay. All right. The substitution, what's your new problem? From 1/2? Oh, 1/2 out front. I'm with you. Got you. Secant squared stayed, yeah?
Yes.
Inside becomes u and du, and the half out front with it, yeah? Limits of integration. When x was 0, what's u? Negative pi over 6. Again, based on that u choice. If u is pi over 6, then, sorry, if x is pi over 6, then u is pi over 6. 2 pi over 6 minus pi over 6 is still pi over 6. Cool. Okay? All right, what is the antiderivative of secant squared? Tangent. That's one of the derivative rules that hopefully you're getting into your brain. That derivative of tangent is secant squared, so we're undoing. So I have 1/2 the tangent of pi over 6 minus the tangent of negative pi over 6. Tangent of pi over 6, is it root 3 or root 3 over 3? Root 3 over 3. Tangent of negative pi over 6. Is that root 3 or negative root 3 or negative root 3 over 3? Negative root 3 over 3. That's subtracting the negative. So I get 1/2 times root 3 over 3 minus negative root 3 over 3 is 2 root 3 over 3. So our final answer is root 3 over 3. All right. This is a very common AP kind of question. Try that one on your own, and we'll be done in 10. Careful with the du here is my warning. Okay, so what's your choice, A, B, C, or D? What? It is D. Okay, it is D. That's it. All right. That should be good. Would you go to the homework and go to section 2 and just underline 2 words for me? When necessary. Okay, not every one of those problems is U sub. You need to judge when U sub is appropriate and use it when necessary. Okay, that's it. Questions on set? We still have set 50?
Yes.
Set 50 question.
Number 7.
7 and 23.
No, not.
Not 23. You lied to me. 7. Do I have replacements on here we can go over? Okay. Strangers in the night. Where are you at set 50? Nowhere. Okay, did we do 3 and 4 as warm-ups, I think?
We did all of the ones except for 7.
7? Okay.
It doesn't matter.
7's easy. And how about these? Did we do any of these, all of them? I will just throw those up there. How's that sound? Okay, boom. All right, so looking at 7 and seeing if you had the right idea. Did you, first of all, take your derivative with the chain rule and get that? Okay, do you agree that e to the x squared cannot equal 0, but x equals 0 would be critical number, right? All right, in terms of the first derivative test, we test around the critical number to see the sign of the first derivative to see if the function is increasing or decreasing. So, in a negative territory, this is always positive, but this guy would be negative. So we get negative outcomes. If f prime is negative, that implies f is decreasing. I go flat at a place where the derivative is 0. After 0, if I put in a positive number, positive is positive first derivative, which implies the function is increasing. So by the first derivative test, I would conclude that f has a min at x equal 0 because what? F prime changes sign from negative to positive. Right? That's what the first derivative test looks like. Compare that to the second derivative. Now I found where f prime is 0, so I know a flat spot. The second derivative test then says, forget before and after increasing, decreasing. Talk to me about at that point, concave up or concave down. So after you found the flat spot, which I don't have to redo, you're going to find the second derivative and test it not around that point, but at that. So the second derivative would involve taking the derivative of this, which would mean product rule, right? And chain rule, correct. So first stays the same, e to the x squared. Derivative of the second, what's the derivative of 2x? 2 plus second stays the same, 2x. Times the derivative of the first, what's the derivative of e to the x squared? E to the x squared times another 2x for our chain rule, right? If I were to, normally I clean that up, but 0 is so nice to put in, I don't really need to. I get e to the 0 times 2 plus 0. What is e to the 0? 1, so I get 2 out of this. 2 is obviously positive. If the second derivative is positive, then the curve is concave up. If I have flat with concave up, I'm looking at a min, and the conclusion would go something like this. F has a min at x equal 0 because, and for second derivative test, you cite two pieces of evidence. F prime is 0 to get the flat thing identified, and F double is positive or greater than 0 to get the concavity. That's what the second derivative test should read like. Okay. With me? Okay. Moving on to the backside replacements. I didn't listen carefully to you. Did we do this guy next to 23 yet?
No.
Okay. So find the intervals. This is a good one. This is really a matter of being taught how to organize this well. All right. At least the way I was taught. So find the intervals where this is both concave up and increasing at the same time. I like to think of this as supercharged. Let's call this f prime equals 3x squared minus 6x minus 9. Back in the old geezer days before we had graphing calculators, we would go superchart. I could find where the first derivative is 0, and I see the derivative is 0 at negative 1 and, negative 1 and 3, yes? Boom. I will hold off on the sign chart and we'll pause for a second. Now let's go to the second derivative. What's the second derivative? 6x minus 6. Now that could turn concavity or change concavity around its 0. So I'm going to find its 0 also, and I think you'll agree that its 0 is at 1. Now, in terms of all the interesting points, for either number, there are three interesting numbers here. Negative 1, 1, and 3. So let's go with intervals. I would start from the far left, negative infinity, and the first one I come to is negative 1. The next region would be from negative 1 up to my next point of interest, which is 1. Then I would go from 1 to 3, and then from 3 to infinity. Now I want to test both the first and the second derivative here. Supercharged. All right. Now, the derivative, let's talk the signs of the derivative here. Isn't that going to be something like a parabola shape around those zeros? And so what's the behavior of the signs of the first derivative? Positive before negative 1, negative between negative 1 and 3, and positive after, yeah? So it's positive. In here, from negative 1 all the way up to 3 for both of these, it's negative. It didn't really do anything at 1 because that was a second. And after 3, it's positive. Right? Now the second derivative, that's here. How will it behave sine waves? It's all about in relation to 1. Do you agree? So before 1, I'm looking at negative. So negative, negative, then after 1, positive. Now with that chart, boom, you're home free. The question is, find the interval or intervals where it's concave up and increasing. Concave up, I need to look where the second derivative is, positive, and increasing means I need to know where the first derivative is, positive. So I need to find a place where the first and the second derivative are positive. Where are they? 3 to infinity is the only place where they're both positive. F is increasing and concave up on 3 to infinity or 8. Because F prime and F double. Okay. All right. Yeah.
If the chart is that necessary, or can you just
No, you wouldn't have to do the chart. I feel like it's a good tool to organize it, but they wouldn't, on an AP question, they wouldn't have a point built in for each.
Okay, so I could just do this on.
Sure, their rubric would be, finds the critical numbers or the zeros to the first derivative, finds the zeros to the second derivative, and makes the appropriate conclusion. Okay? Good question. All right. The derivatives of each of the six we did that, I think. Sketch, do we do this guy yet? Okay, so my goal is that you can do curves, this is called curve sketching. It's a big part of calculus. So remember, the derivative tells you increasing or decreasing, and the second derivative tells you concave up or concave down. So in this first region, before 1, I'm looking at increasing concave down. So here's concave down, but I only want the part that's increasing, so I'm only going to take this piece, increasing concave down. In the next region, I'm talking what kind of behavior? Decreasing concave down. Here's concave down, so that's this piece. Okay? Now I talk what behavior? Decreasing concave up. Here's concave up. Decreasing concave up would be this piece. So decreasing concave up. What happened at 2 then? If the second derivative just changed signs, that at 2 there is a inflection point. Yeah? At 3 it starts to be increasing concave up. And so that's, in other words, that sign chart could represent a cube. You follow?
Yes.
Okay. The next one, the interesting points are 1, 2, and 3 again. From negative infinity to 1, it's decreasing concave up. It helps me to draw concave up and concave down. Decreasing concave up looks like this. Then increasing concave up, which looks like that. Then increasing concave down, which looks like that. Then decreasing concave down, which is that. So I'm feeling a negative QB. Okay? With an extrema at 1 and 3, and inflection at 2. Cool. All right, other questions? You said 7. Is there anything else on 50 you want to even put up? Okay, 7. Here we go. 7, is that 7 the one I already see? Oh, 7, this one?
Yeah, no, here.
So I'm good. Okay, yes. 24, sure.
Wait,
24. Okay. So I gotta remind myself that this is g of x. All right. They want g prime at 0. Okay. I think you'll agree that g is a function within a function, so we'd have to use the chain rule. So start by taking the chain rule derivative. Derivative on the outside would be 2 comes down, drop it to 1, and the inside stays the same.
wait, couldn't you just do it as
Yeah, so you called it f times f?
Yeah.
Good, you could use a product rule. Is that better?
Yeah, it's fine.
I don't think so, but sure, okay, whatever you want.
Because it gives you f prime.
F prime plus f prime f. I still don't. I feel like this has 2 things to substitute. You have 4.
But they're all the same number.
Okay. You say tomato, I say tomato. I'm right, you're wrong.
I'm right.
All right. It's good that you saw it that way. I love that you see things more complicated. So f of 0 is -1 and -1, so good to know. Does that make sense? Other questions on 50? Okay, how about 51? Are there replacements to give answers to the 51?
Number 1 is so
1.
so 18.
18. 1 and 18. Oh. Are any of these replacements you need answers to, by the way? One is? Okay. Oh, one's a great one. It feels like too many variables, yeah?
No, it feels like really hard.
It's easy.
Can you do number 5?
Here's a light. 5, did you say?
No.
You didn't say 5? Here's the old 9-foot lamp post. Anytime you do related rates, be careful to identify it as a constant or variable. Does that lamp post change? Is it always 9? Yeah, it's always 9. Okay? And a trick-or-treater is walking away from the lamp post. Away? A man walks, let's go with the trick-or-treater. A trick-or-treating man, get a job, walks away from a lamp post. Okay? And the tip of his shadow moves twice as fast as he does. What? He's walking. What? That's exactly what you look like when you're walking.
Yeah, I got a small body.
All right. This distance, what did you call it? What did you call it? It varies. X, okay. This shadow distance, what did you call it? It varies also. W? Okay. In terms of what you're given, I got a picture. What about the height of the guy? Do I know it? No. Does it?
Twice.
So that,
That's what the
we want to know. It's all called, do you call it H or Y?
H.
Okay.
Good morning, Dublin Jaguars. Please rise for the Pledge of Allegiance. Please begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Pumpkin decoration judging will take place today during the 7th hour. If you would like to see the entries of the first movement team who have entered the most creative, most artistic, or spookiest pumpkin, join us in the cafeteria today.
So you're given
We have an orchestra student. We want you. Come be a part of the musical, curtains and play in the
WTT is twice. That's my given. Do you agree? Okay, what's the math relationship? Similar triangle.
Are you a basketball fan? Scar McLaughlin University in Spokane, Washington will be here. A new arena was built in 2004, and it has been a packed house every game since.
Everyone in the Dublin community, today is the last day to enter the My Favorite Book drawing in the library.
That's pretty clean, I guess. Are we ready to differentiate?
Are due now 10 line for the Senior Space Engineering Lab Saturday, this Friday at 1:30 p.m. If you are thinking about a career in engineering and would like to create and make your own fidget spinner,
Okay, so what's the derivative of the left with respect to time?
9W
The UNC math competition is one of the biggest and most fun math
Okay,
competitions.
so product rule here.
Head break questions that get progressively harder and involve outside the box. Competition is tomorrow and their first and possibly second period in the cafeteria. Few math teachers for a prearranged outing or make yours.
Okay, so I imagine you used a product rule there.
Jaguar. That crisp fall air will
Do you
be
really
used
need a
for
product
your
rule there?
glass. Before
Why
that
not?
happens, please check your closets for
Okay, I guess you could take out an H, but why else not? H is a constant. Okay, so if you did the product rule, you would get the HDTs. What's the HDT?
Your donated items will be cleaned and distributed to needy
Zero.
Colorado residents.
And the height does not change. And so the easiest way to deal with this, maybe you're right, maybe I should have left it
High school students,
out.
don't forget that there will be a break meeting right after school today in the auditorium for those who
H is a constant.
teachers musical courtesy. Audition materials will be available at the meeting.
Okay?
No previous experience is necessary, and all are welcome.
So if I leave H out,
Junior high students at the Littleton Jump Street on the early release date is Friday, November 2nd, 12:30 to 2:30 p.m. Pizza and bottled water is included.
you
Get
with me?
together with your friends in this fun event.
Okay, now you're almost there.
Waiver
You
must be
know
completed online prior to arrival or
this.
print it off and bring with you. That's all your announcements. Have a great day.
So if you use that, then it's 9 times 2 dx dt equals H times dx dt plus 2 dx dt's, or 18 dx dt's equals H times 3 dx dt's, and so H is 6. All right. If you use the product format, it's considerably harder, and you just would have to make the connection with the HTTs here. 50 is due today, but 51 you can keep until. They're easy. Nope, all easy. No, for everybody. Everybody finds them easy.
Then I guess I'm done.
No, you're psyching yourself out.
Sounds like I'm not.
Psyching yourself out. No. Yes, I know. No, actually, more like.
I was like, okay, 6.5, and then I was like, okay, 3.3, and I was like, 3.6. Whatever.
Women have considered
Like, whatever, just give me that 2.7.
Howdy. Nope, don't take it.
Okay, so is it, you?
So your first overarching thought is how can I make my life easier? New stuff does that, but here I would do something totally different.
I thought originally it was just all in.
If you can make your life easier by making it a sum, that's the key. Could you make this a sum instead of a quotient?
Yeah.
Yeah, and just treat it. Or just put them each individually. So this is equivalent to x plus 1 over x.
Okay.
Boom, you're wrong. Okay?
Thank you.
You're welcome. Hi. Are you doing a math competition? Yeah, next year you'll be sorry.
I
Yes.
forgot to do the PE test for it. I had like 2 more to do.
7th grade?
And you went to the
Sure.
Sweet.
You're welcome.
We're learning about transcendentalism and I will not get in my mind class tomorrow.
Have her record the lesson. Get somebody's notes.
Can I have a test?
No, you cannot have a test. What test?
I want a test.
I can't even count your test until you give me problem set from last week. You did with me. You're missing a set.
Yeah?
Yeah, you are. Remember that day you didn't have your homework? I need that from you.
Mr. Pam, when are we going to learn that?
That is 4, 5 years. 5 years. Hey,
Hey, you definitely don't want that flank.
tubes.
Oh, shoot, I forgot to stop this recording. What?